My name's Darryl Gove. I work in the compiler team at Sun Microsystems doing performance analysis and things like that. I'm going to say a few words about performance and optimization. And there are 2 points I really want you to take away from this little video clip. And those 2 points are always profile your application and always optimize your application. So let's first start with the first of those. Profiling. In Sun Studio, we have a tool called the Performance Analyzer. So this tool is our primary profiling application. It enables you to see the time spent in your application at the level of the routine or at the level of the disassembled code. And if you compile with a debug flag, which is -G or -G0, you can see the time attributed to lines of source code, which is a much more convenient way of seeing where the time is being spent. Now, moving on to optimization. In terms of optimization, the basic rule is that if you don't provide optimization flags, you don't get any optimization. So you should at least use -O, which represents a good trade-off between compile time and runtime. The other flag you want to probably try out is -Fast, which we find to be a flag that gives a good performance over a wide range of applications. It enables a lot of optimizations that we find to be beneficial. So one of the other flags I'd like you to consider is -XIPO, which enables cross-file optimization. So cross-file optimization is where you have routines in multiple source files, and you take the routine in one source file and inline it into the routine in another source file that calls it. This does 2 things. First of all, it removes the cost of the call instructions, and second, it enables the compiler to look for further opportunities for optimization. This might be like dead code elimination or something like that. The other technique that can be useful is profile feedback. In this, it's a 3-step process. In the first step, you build an instrumented version of your application. In the second step, you run it. And in the third step, you build the final version, which uses the data gathered during the instrumented run. And this helps the compiler to make the right decisions about which routines to inline and how branch statements are likely to be taken. And this is particularly effective for what's called branchy code, where there's a lot of branch instructions, because that sort of code is often tricky to optimize using other techniques. The final thing that you'll want to do is to use the instruction set extensions that are available in your AMD processor to get the best performance for that particular processor. The flag that identifies and optimizes the code being generated for the particular processor that you're building on is called -X target equals native. So this flag will enable the compiler to pick the appropriate mix of instructions and use the instructions that are implemented in the hardware to the best benefit. You use this flag together with the flag -X vector equals SIMD, and this flag tells the compiler to recognize situations where it's possible to use SSE instructions to improve the performance of the generated code. So to conclude, there are 2 things, as I said at the beginning, that I really want you to remember from this little clip. The first is to always profile your application, and the second is to always use some degree of optimization. Thank you.